Okay. Well, hi. Kind of looks like it's just the two of us. Welcome from Richmond, Sean. We'll see if other folks trickle in, but otherwise, if this is us, that's totally cool. So what we're going to cover today are fractions. And I would say fractions are one of these super important fundamental topics that you're going to encounter in the quant section of the GRE. I usually tell my students, if you want to improve your quant score, get better at fractions and percents. Why? Because they show up all the time. There's stuff on the test that's sort of harder that shows up occasionally, things like probability, combinatorics. But like, you're going to see one or two of those. You're going to see like 8 to 10 things like this. So what I want to cover today are the basics of how fractions work, how to estimate with them, what the mechanics are, so you can be rock solid on that, and then how to translate word problems. And once we do that, then we'll just do some practice problems, incorporating all the stuff that we've covered. So hopefully by the end of this, you'll be able to do fractions problems, at least have the tools to do them with some confidence and know what you need to keep working on. All the skills we do today are the kinds of things that are worth practicing regularly enough so that they become almost automatic, so that you can add fractions together as easy as you write your own name. So what a fraction is we're talking about a part of something, right? And so I can say it's a quarter of this circle is dark blue. And I could express that as a fraction, which expresses that dark part as part over the whole. And this is kind of our general idea of what a fraction is. The fraction is the part over the whole. I could also express it as a decimal out of 1, as a percent out of 100, or as a ratio, where I'm relating one part to another part. And it's worth getting good at these three definitions. But for today, we're going to focus solely on fractions. So if I'm asked what fraction of this is dark blue and the fraction is the part over the whole, well, I could say there's 6 slices are light blue over the total 8 slices, or 2 slices dark blue over the total 8 slices. Now, I can take that same fraction, let's say just to stick with the dark ones, 2 over 8, and rewrite it in different forms. So 2 over 8, or I could call that 1 over 4. And I'm doing that simplification by dividing the top and bottom by the same number. It's got to be the same number, otherwise I'm changing the fraction. Or if I multiply the top and bottom by 2, I can say 4 over 16. And these are all equivalent to each other, and hopefully you can see why. Now, this big idea of the equivalence between fractions is going to be really important to us as we get into the mechanics of them. Before we get into that, though, I'm going to just think a little bit about how we can kind of read a fraction and know what it is. So if you've got a fraction here, a part over the whole, 3/7, say, and I want to make it larger. Well, the way to make it larger is a bigger part of a smaller whole. So the top number, the numerator, gets bigger. Bottom number, the denominator, gets smaller. To make the whole fraction smaller, I would do the reverse. Smaller part of a larger whole. So I can compare numerators and denominators here. I could also estimate and say, well, this is a little less than 1/2. And this kind of comes with experience. It kind of comes by knowing, 3.5 times 2 is 7. This is a little less than 1. Right? If I had 5/5, that would be 1. Okay, so this is going to be greater than this. This is a little less than 1/3, knowing that 3/9 would be 1/3. Okay, so that would be less than this 4/5. It would also be less than 3/7. And so this is called using benchmarks. And so some common benchmarks to think about are, 1, 1/2, 1/4, 1/3. And if you can kind of relate things to those, you can at least get a sense of where things lie. So the first exercise I'd like us to do, just to warm us up into this, is I've got here a number line from -1 to 1, and a bunch of fractions here. And I'd like you to take a minute and put these fractions in order on the number line. And when you're done, you can just let me know in the chat that you're done. See, where do they go, approximately? You may want to draw this on your page first and then write all these in. All right, great. So if we look at this number line, we can set these up. So actually, let me go back and I'll set it up here. So 5/19, how am I looking at that? Well, 5/20 would be 1/4. So this is about 1/4. I see it's positive. I'm going to put it about here. -2/3. First of all, we're dealing with a negative. 2/3 less than 1/2. That's going to go about here. 34/70. That's right about 1/2. I'd put that like right there, just below it. -2/13. So it's negative, but it's pretty small. 5/2. That's more than 2. Somewhere up here. -15/7. That's less than -2. So an exercise worth doing. Again, I'm using benchmarks, these benchmarks specifically to compare things, but then also thinking about things like 1/4, having a sense of where my thirds are. And looking at that all together. So let's deal with the mechanics now. So that's great that you got them right, except for the -2/3. Awesome. So if this is a necessary skill to be able to just kind of look at a fraction and have a sense of what's going on, we also need to know how to actually calculate with them. So first thing, if we're adding or subtracting, we need to have a common denominator. So in order to add these two together, they need to both have the same number in the bottom. So the way we're going to do that is to convert these thirds into sixths. So multiplying the top and bottom by 2, I get 4/6 plus 1/6 gives me 5/6. That's kind of the most complicated one, adding and subtracting, because you have to get that common denominator. Multiplication, much simpler. You're just going to multiply across the top and multiply across the bottom. But a good thing to get in the habit of is, rather than just doing 2 times 3 is 6, 3 times 4 is 12, 6/12. Before you do that, see what you can simplify. So I see I've got a 3 on top and 3 on bottom. Let's cancel those out. So I've got 2/4. Oh, I can cancel that out into 1/2. Most of the time on the GRE, and generally speaking in terms of even if the answer, most of the time in the GRE, the answer is going to be in the simplest form. So if you got 6/12, you'd have to convert it to 1/2 to match it with an answer. But also, if you're just doing math using this, it's much easier to work with 1/2 than it is 6/12. So you want to get in the habit of doing this before you do that multiplication. Division is very similar. Like multiplication, we're going to simplify before we do the action, but you have to flip this second part and then multiply. So 2/3 divided by 3/4 is 2/3 times 4/3. And now here we ask, can I simplify anything? Well, actually I can't, so I'm just going to have to multiply across. If I've got a complex fraction like this, well, keep in mind that a fraction is just division. So I can just rewrite this as 5/6 divided by 15/24, or in other words, flip and multiply 5/6 times 24/15. I do my simplification, call this 3, call this 4, and what do you know? I've got 4/3. So I'm going to put a couple of these on the board. Let me know when you're done. You can try some of these skills out. Okay, so let's go through these answers. This first one, in order to subtract, I first need a common denominator. That's going to be 10 in this case. So I multiply this by 2 over 2, this by 5 over 5. I'm getting 3 over 10. To add here, a little bit easier than this. I'm just going to get this into eighths and add together to get 7/8. Multiplying here, I'm first going to do simplification. So 20 over 15, change that to 4 over 3. 6 over 3, change that to 2 over 3, and I end up with 8/3. Very good so far. This complex fraction, I'm just going to think of as division, which means I flip and multiply. Can't do any simplification. And then, which is greater, 3/5 or 4/7? Okay, 3/5, a little bit over 1/2. 4/7, also a little bit over 1/2. I would also use a calculator here. This is a case, and look how close that is. So it's great to know how to estimate fractions and know which one is bigger. It's also really important to know when it's worth pulling that calculator out. Great. So let's make things a little bit more complicated here. If I have a complex fraction like this, we need to think of this bottom portion as being in parentheses. I have this thing divided by this difference. So I can't do the flip and multiply yet. First, I have to get it that this is only one term. So I'm going to start by doing my subtraction. Get a common denominator and subtract. Once I've got a single fraction, then I can do my flip and multiply and solve. So I'm going to put one on the board. You try this. Send me your answer when you have it, please. Okay. So to break this down, we have to start, with that numerator and get this to just be one term. So let's rewrite 3 as 6/2. So I get 7/2 divided by 1/4, flip and multiply, cancel out that 4 and that 2, and we get 14. Another way you could do it, because this is in the denominator, you could start by flipping and multiplying and then distribute. Perfectly fine way to do it. Or use the calculator, use decimals, or know that this is 0.25, that this is 0.5. So 3.5 over 0.25. You'd ask to bring out the example again. Is there anything on here you had a question about? This one. Did you have a question about this? Got it. Okay, cool. Sean is asking if he could look at this again to try it again later, and great idea. Anybody else watching on YouTube, I would suggest the same. So let's go ahead a little bit. Oops, we just did this. All right, so sometimes you may see something like this. And I would say this is pretty annoying, because to do this, I would have to get all these common denominators. It's a lot of work. So keep in mind, adding fractions, subtracting fractions, kind of a pain. Sometimes it's the best way to go, but sometimes it's best to just turn things into decimals. And you can use your calculator for that, but it's also really helpful to know some of these conversions. That 1/10 is 0.1, 1/2 is 0.5, 1/5 is 0.2, 1/4, 0.25, 1/20th, 0.05. I have a hard time remembering that, but you can think of it as like half of a tenth. If a tenth is this, half of that is 0.05. So 3/20ths would be 0.15. You know, if you have to use your calculator for that, that's okay. But these, hopefully, you can get there just knowing them. It's really worth memorizing those. And if you have these as decimals, it's a lot quicker. So generally, decimals are faster for addition and subtraction. All right, I've got one more little mechanics quiz before we move on to start thinking about word problems here. Let me know when you're done with these questions. Okay, let's go through these answers. So a lot going on here, so let me try to simplify this and work it out bit by bit. So for this first one, just to reduce, we can factor this out and cancel those common factors. For our second one, to do this addition, we need a common denominator. So we'll multiply this first one by 3 over 3, get it as over 45, add those together. Number 3, a little trickier, but it's the same principle. I'm adding fractions, so I need a common denominator. In this case, that common denominator is going to be xy. So I multiply this by y over y. I multiply this by x over x. These now have the same denominator, so I can add them together. Number 4, I want to cancel before I multiply. Number 5, I've got my complex fraction. I flip and multiply, but I still cancel first. And this last one, we need to work that denominator, get that to be a common denominator here so we can combine them, and then flip and multiply. As far as the extra credit goes, looking at this, I might say, okay, this number is greater than 1. Maybe I even know it's 1.5, 1.5. Here I've got something a little more than 1 minus something a little less than 1. That all tells me this is going to be positive because this is less than this. I also know that I'm going to have a small denominator. My denominator is less than 1. And if I'm dividing by something less than 1, my numerator gets bigger. So my result has to be bigger than 1.5. If you're able to do that, you can make some difficult problems quite easy, because then you can eliminate answer choices. Anything less than 1.5, I don't take. Any questions about these? Great. So let's work towards GRE problems. So I said the fraction is equal to the part over the whole. If we think of it, if we have that definition in mind, fraction is the part over the whole. I might look at something like this and think, okay, can I use that here? Well, 2/5 of a 10-slice pizza is how many slices? Okay. Well, that of means multiply. So I can say 2/5 of a 10-slice pizza, 10, is my equal sign. How many slices? 2/5 of 10 is 4. So that's the first method that you can use, which we can call direct translation. The other method you can use is what we might call the formula method. And think fraction is the part over the whole. So my fraction is the part, that's what I'm looking for, over the whole. And I write out my equation this way. And then solve for x. I multiply both sides by 10. And solve from there. Which method you use, direct translation or the formula method, up to you. For me, I usually like translation better, but I'm a little weird in that way. A lot of people really like the formula method. I think try them both, see whatever feels best for your thinking, whatever makes these the easiest. So I've got a couple here. Try these out. Send me your answers when you have them, please. Okay, so for this first one, what fraction of 5 is 2? I'll give you one other way to do this. So first way is what fraction of 5 is 2? We solve for x. X is 2 over 5. Or you say the fraction is the part over the whole. It's a little hard to tell what the part is and what the whole is here. So one way to think of it is over of. Is over of. I'm giving you a lot of different tricks here just because what's going to work for each individual is going to be different. What's going to be most helpful for each problem is going to be different too. So 3 is what fraction of 7? We could say 3 is what fraction of 7? Get 3/7 equals x. Or we could think is over of. What fraction is 5 of 8? Is over of. Whatever way works best. Or you could say what fraction is 5 of 8? Wait a second. What fraction is 5 of 8? Oh man, that one doesn't work there. Here I would do is over of. Okay. Let's try a couple more. So here we've got kind of a full word problem. And for this kind of word problem, I think thinking with the formula is really helpful. So I want you to try this, and then I'll walk you through a solution that I think is clear. Okay. So we're told 2/5 has peppers and 1/5 is mushrooms. How many slices have peppers or mushrooms? So 2/5 of the 15 have peppers, so it's 6 slices. 1/5 of the 15, 3 slices. If each has only one topping, how many slices have peppers or mushrooms? We add those together. So this is a case where I think direct translation is a little easier than thinking with this. If we wanted to think with this, you could say, all right, the 2/5 is the part over the whole. And that gets us to 6 if we multiply both sides by 15. And similarly, we could say the 1/5 is the part over the whole. Multiply both sides to get that part. So to recap all of this, for our mechanics, we need to get a common denominator to add or subtract. We need to be able to rewrite fractions, either larger or smaller. To multiply, we multiply across but cancel first. For division, you multiply by the reciprocal. You flip it and multiply. To compare, you can compare relative size at the top and the bottom. Benchmarks are super, super helpful, as are decimal conversions. For translations, the number after of goes in the denominator, is over of. Or you think of the fraction of means multiply. So let's try some of these out on some GRE type questions. Now, this first question is what's called a QC, or quantitative comparison. Your job is to compare the two sides. The answer choices are always the same, and I've got them written out here. Basically, you pick the bigger side, you pick C if it's equal, you pick D if it can't be determined. In other words, if it depends. So I want you to try this and send me your answer, A, B, C, or D, when you have it. Okay, so first way I can do this is to actually solve it out. So I can call this 3/4 times 6/5 and do a little bit of canceling here and get 9/10. And then here I can say 1/3 times 7/8. No canceling to be done. I get 7/24. This is close to 1. This is a little less than 1/3. So my answer is A. That's way number 1. Way number 2, I plug each of these into the calculator, get decimals. So it's kind of a lot of calculator work. Way number 3, this is, 0.75. This is a little less than 1. This is more than 1. So if I'm thinking about this, dividing by less than 1, this is going to be bigger than 0.75. Here I've got a smaller numerator, larger denominator. This is greater than 1. So this is going to be less than 1/3. And since my only job is to compare, I don't really care what these numbers are. I might know my answer is A. So on QC, when you see fractions on QC, think about estimation. Let's try another. Take a deep breath. Send me your answer when you have it. Okay. So one way I could do this, of course, is to actually add it out. But if I take a look at my answer choices and I'm careful about what the question is talking about, I realize I don't need an exact answer. I just need an approximation. So the best method here would be to estimate. 13 over 15 is more than a half. So it's not going to be A. 13 over 15 is greater than 2/3. So again, too small. All right, now we're kind of maybe in the right place here. Here, well, this is 13 over 15 is less than 1, and this is really small. It's not going to be greater than 1. So we can get rid of these two. We're only left with C. So part of the business here is, can you use your rounding, say a little bit less than 1, really small, and use that to get you in the right ballpark? Maybe the GRE would ask you a question like this. Honestly, I haven't seen it too often, but if you can use this skill, maybe it can help you on another problem that's asking you about a specific example. Send me your answer to this when you've got it. All right, sort of a tough capstone problem here. What I want you to keep in mind is when you see a multiple choice problem like this, before you get started, look at the answer choices. And in this case, you might notice there's quite a bit of variation from -3 3/5 to +3 3/5. If you see there's a wide spread, you might want to estimate. So let's think about how that could work. All right, I want to know like basically where am I going to fall here? So I've got 3 minus 1/3. So that's like 2 2/3 over 1 minus 1/3, so 2/3. Now this is less than 1, so this is going to be bigger than 2 2/3. Something like that. Now, what am I subtracting here? 1 over 2.5. 2.5 is greater than 1. So this is something bigger than 2 2/3 minus something smaller than 1. That already tells me it's not going to be negative. So I can get rid of A, B, and C. And now I'm thinking about, okay, something that's less than 1 or something bigger than 3. Well, for this answer to be less than 1, this big number would have to be subtracted by something at least, if it's bigger than 2 2/3, maybe I think maybe it's 3. For it to be less than 1, this would have to be like more than 2. And it's not. So I don't exactly know how big this is going to be, but I have to guess it's going to get fairly big because I'm only subtracting something small here, and it leaves me with my only choice, E. If I wanted to actually solve it out, I of course could. And let's do that before we finish up. I could make this 9/3 minus 1/3 over 3/3 minus 1/3. Turn that into 8/3 over 2/3. Turn that into 8/3 times 3 over 2. Cancel. And get 4. And notice I decided to just take care of all of this before I even dealt with the second term here. Minus 1 over, I can call this 4/2 plus 1/2. So 1 over 5/2, which gives me 1 times 2/5, which is just 2/5. 4 minus 2/5. Well, I see I'm dealing with a mixed number here, so let's just call that 3 3/5. If I didn't go directly there, I would call this, multiply this by 4 over 4, 16, 4, sorry, not 4 over 4, 5 over 5. Call this 20 over 5 minus 2 over 5 gives me 18 over 5, which then I convert into a mixed number this way. Or I say, you know what, that's bigger than this, it's bigger than this, bigger than this, bigger than this. It's got to be this. So a lot of work to do this, a lot of work to do the estimation as well. And so if I'm going to leave you with one thing, let it be practice these mechanics enough that you can do steps like this without breaking a sweat. Because you're going to see problems that you have to do a lot of calculation, a lot of estimation, a lot of just working with fractions, that you want to get the mechanical and conceptual part of it clear enough that you don't have to worry about it. Any final questions before I turn off the recording and we can chat for another minute or so? Okay. Well, I want to thank you for a wonderful session. I'm going to now stop the recording